I think this is your first time. It's about
It is.
time. Welcome to the family. Love it, love it, love it.
Excited.
Yeah, and Reese, nice to meet you as well. Thank you for joining us, and we're going to bow out behind the scenes and let you take it from here.
All right.
Thank you. I'm so excited. Thank you for having us.
Okay, well, here we go. Well, welcome everyone. Thanks for joining us today. And like I said, we're super excited to be here. First Cube Crush, I think, for both of us. Let us introduce ourselves before we get started. So my name is Adriana Villela. And as Lisa mentioned, I am a CNCF ambassador. I'm also a blogger, podcaster, and one of the maintainers of the OTel and user SIG alongside Reese. By day, I am a principal developer advocate at Dynatrace, and I spend most of my time in the observability world. And by night, I like to climb walls at my local climbing gym, and I also love capybaras because they make me happy.
Hi, everyone. I'm Reese. I am a senior developer relations engineer at New Relic. I work alongside the lovely Adriana on the OTel community and user SIG. In my off time, I love horror movies, landscaping, and jujitsu. You can usually find me eating when I'm not bouncing around doing all the observability things. And yeah, we're really excited to be here. And let's get started. So here is how we've organized our session for you today. We're going to start with a high-level overview of the OpenTelemetry Operator. And you're going to hear me probably bosh that out a couple more times. And then we're going to cover how to install it, how to deploy the collector with it, which will be the third section. And also the fourth section, we will cover how to use the operator to inject auto-instrumentation into your pods. And in each of those three sections, we'll also cover commonly encountered issues, as well as the resolutions. And finally, we will wrap up with some takeaways and share reference materials for further learning and hands-on experiments. All right, so what exactly is the operator and what does it do? If you already have an application running in Kubernetes and you're exploring using OpenTelemetry to gain insights into the health and performance of your application and cluster, you might be interested in the operator. It's responsible for two primary tasks. First, it manages the deployment of your collector and makes sure it's correctly configured in your cluster. It also manages configurations across a fleet of collectors via OpAMP, which is a network protocol for remotely managing large fleets of data collection agents. Secondly, it is responsible for injecting and managing the configuration of auto-instrumentation into your Kubernetes pods, which Adriana will go over more in depth in a later section. So now let's learn about what we need to install the operator and how to do so, and then we will go over some commonly encountered issues and how to resolve those. So the first thing might seem obvious, but before installing the operator, you must have a Kubernetes cluster that you can install it onto running at least on version 1.23. You can spin up a cluster on your local machine using a local tool such as Minikube, Kind, or KOS, and use a cluster or use a cluster running on a cloud provider service. Next, and this is less obvious. If you're going to use Cert Manager, it's not required, but if you are going to use Cert Manager, it must already be installed on that cluster. This piece makes sure your Kubernetes certificates are valid and up to date. And if you don't want to use Cert Manager, there is a way to get around that. You just have to provision the appropriate TLS certs in the right places. And finally, to install both the Cert Manager and the operator, you can do so via either kubectl or Helm chart. And that is the third point here. Yes. And we've included the commands for both in the following slides, so you can reference them after our session. So taking a look here, you will install Cert Manager and then operator using kubectl, using these kubectl commands. You can also install using Helm. Note that version 3.9 at least is required, which you will see pop up here in a second. And this step will take up to a few minutes, but once that's done, you can install the operator. using these commands. And yes, we're kind of just going through them, but this deck will be available for you to reference afterward. We just wanted to include them so you have something to reference. Do you note that in either case, you have to wait for Cert Manager to finish installing before you install the operator? Otherwise, the installation will fail. All right. So once you have Cert Manager and operator set up in your cluster, you can now deploy the collector. So for those of you who are not familiar with the OpenTelemetry Collector, it is a pretty essential piece of OpenTelemetry. For testing purposes, you can set up quickly without using the collector and just sending your application telemetry straight from your SDK to your backend. But for a more complex setup and to do more data processing, you will definitely want to utilize this component. The collector is at a high level, a vendor-neutral service that ingests data from a variety of sources. It transforms that data into in any number of ways, depending on how you've configured it. And then finally, it exports that data to one or more backends of your choice. It is also additionally supported by functionality that includes connectors and extensions, which for the purposes of this talk, we won't go into, but just so you are aware. Okay, so the operator has a custom resource, or CR, for managing the deployment of the collector. This is called OpenTelemetry Collector. This is a sample OpenTelemetry Collector resource that we are showing here, and there's a few things that we do want to point out. So first, and you'll learn later why this is important, the API version here is v1 beta 1, and the kind is OpenTelemetry Collector. Okay, so depending on how you plan on instantiating it, there are many configuration options for this resource, but the basic config requires two things. So the first thing is the mode attribute, which should be either deployment, sidecar, daemon set, or stateful set. And in this example, it's set to stateful set. If you leave it blank, it defaults to deployment. And next we have the config attribute, which contains the collector configuration as its value. And so if you, Adriana, if you click on, yeah. So this is the, oh, sorry. So what you saw, what we had highlighted just now was the collector configuration. You're so good. So yeah, this looks familiar. It is because it is actually the collector config configuration included as part of the custom resource. And then one more thing that we want to call out on the next slide is that if you have specified the mode as sidecar, there are some additional things you will need to do, which we will cover as we go. In this case, you'll need to add an annotation to your deployment YAML file, which we have highlighted here for your reference. Okay, so what happens when you deploy the OpenTelemetry Collector and things go sideways or doesn't go anywhere and you don't see any data? Well, let's look at some troubleshooting tips. So Kubernetes events provide detailed and chronological information about what's happening within various environments, within various components of your cluster. To view events for a specific namespace, so for example, like where your operator is running, you would want to use this command, and of course replace namespace with the actual namespace where your operator and resources are deployed. And you will also want to check whether your resources were successfully deployed. And this is because when an OpenTelemetry Collector resource is deployed, the following objects are created in Kubernetes. You have the OpenTelemetry Collector, you have the collector pod, and note that if you specified non-sidecar mode, you will want to look for deployment, stateful set, or daemon set resources with the following name configuration. And if you've specified sidecar, the container will be created in an app pod named OTC container. Next, you will want to see a config map of collector configurations. Again, if you have specified non-sidecar mode, look for the resources that were stated above. And in the case of sidecar mode, note that the collector config is included as an environment variable in OTC-container. And finally, if you have enabled the target allocator, you should expect to find an object for this as well. Look for a resource named collector CR name, and then the target allocator along with its unique identifier. So when you deploy the OpenTelemetry Collector resource, make sure that these objects were created, and you can do so using these commands that we have listed here. So this one will check that the resource itself was deployed, the OpenTelemetry Collector resource. Next, you can check your config maps. When you deploy the collector using this collector resource, it creates a config map that contains the collector's configuration YAML. So confirm that the config map was created in the same namespace as a collector and that the configurations themselves are correct. We also recommend checking your collector pods, and depending on the mode that you specified, you can use the command listed here as appropriate. So there's one for non-sidecar modes and then one for sidecar mode as well. Another thing that we recommend checking is the collector CR version that you're using. So earlier, I mentioned that the version was going to be important, and this is why. So in the earlier example, we showed you a config that was using the V1 Beta 1 version of the collector CR. There's another version called V1 Alpha 1. So there's two main differences between these two API versions. So to note, the config sections are different. So for V1 Beta 1, the one on the left, the config values are key value pairs that are part of the CR configuration. On the other hand, for the V1 Alpha 1 version, the config value is one long text string. Keep in mind that the text string still needs to follow YAML formatting. Another thing to note is that if you are using V1 Beta 1, you cannot leave the collector config values empty. You must specify either empty curly braces for non-array values or empty square brackets for arrays, which is not necessary if you're using V1 Alpha 1. Also, check the OpenTelemetry Collector base image. By default, the collector CR uses the core distribution of the collector. The core distribution is a bare bones distribution of the collector and just contains a base set of the components that we covered earlier. So extensions, connectors, receivers, processors, exporters. If you want access to more components than the ones that are offered by the core distro, one option is to use the collector's Kubernetes distribution instead. This distribution was made specifically to be used in a Kubernetes cluster and to monitor Kubernetes and services running on your cluster. It contains a subset of components from core and contrib distributions. You can set the collector's base image by specifying the image attribute in spec.image, as in this example. And if that all looks good and you're not seeing data in the backend vendor you're using to ingest your telemetry data, you might need to configure an account license key or some kind of access token. So check that you're using the right one for your account that you're trying to send your data to. And since you want to keep this information confidential, you can create a Kubernetes secret and store it, or use a secrets provider. And finally, confirm that you've configured the correct endpoint for your observability backend in your exporter configuration. It might be shocking or not, but oftentimes that is an issue. And next, I will have Adriana take it away to talk about something really interesting.
All right, cool. I'll power through this and keeping an eye on the time. So we are going to be talking about another cool aspect of the OTel operator, and I'm a huge fan personally of the operator, and that is zero code instrumentation. But first, let's rewind. Now, when it comes time to instrument your code with OpenTelemetry, you have options. So you can either do it through zero code instrumentation, also known as auto-instrumentation, or you can do it through manual instrumentation, or a combination of both. But first, what do we mean by instrumentation? So first off, instrumentation is the process of adding code to software to generate telemetry signal. So keeping that in mind, then zero code instrumentation is when your application is instrumented without requiring you to touch your source code. So magic. Auto instrumentation under the covers uses shims or bytecode instrumentation agents to intercept your code at runtime or at compile time to add tracing and metrics instrumentation to third-party libraries and frameworks that you depend on. So think Python Flask, for example. And at the time of this talk, so far, auto instrumentation is currently available for Java, Python, .NET, JavaScript, PHP, and Go. And you can scan the QR code on your screen to learn more about zero code instrumentation. And then we have, of course, manual instrumentation, right, which requires developers to go in and add traces, logs, and metrics, context propagation attributes, all that good stuff to their own code. Think of it as like adding comments to your code, or like we're already used to, adding log statements to our code, just similar sort of workflow. Now, so the OTel operator, as we saw with the collector, which had its own custom resource, there's a special custom resource for instrumentation, aptly called instrumentation, which is used to automatically inject instrumentation into Kubernetes pods without touching the application code, which is an extremely useful way to instrument your code quickly with OpenTelemetry. Now, here is a sample instrumentation resource definition for a Python app. I'm a big fan of Python. Now, for this here, you'll notice that the API version is v1 alpha 1, OpenTelemetry.io/v1 alpha 1, and our kind is instrumentation. We also have this lovely env array, and this is where you would set the values of any standard OpenTelemetry environment variables that you would like to configure. And you can check out the full list of environment variables on the official docs page at OpenTelemetry.io or by scanning the QR code on your screen. Now, next, we also have the exporter configuration. And this is where you set your exporter endpoint, i.e. where you're sending your telemetry to. And this would typically be sent to that OTel collector that Reese was talking about. Now, we also have this thing called propagators, and this is where you would set your context propagation that your application is using, because there's different ways to express context propagation, so you can pick one or more. Now, propagators are defined as objects used to read and write context data to and from messages exchanged by the application. And we've got some valid propagator values here that include trace context, baggage, B3, B3 multi, Jaeger, X-ray, OT trace, and none. And you can get the full list of propagators by scanning the QR code on your screen. Now, we also have the sampler attribute, which is used to define sampling configuration. And if we omit it, then no sampling will be configured. And please note that sampling is outside the scope of this talk. And then finally, we have this lovely Python attribute here, which is where you configure any Python-specific auto-instrumentation environment variables. Now, if you were doing auto-instrumentation for other languages like Java or .NET, then you would replace Python with Java or .NET or whatever other language is supported for auto-instrumentation by the operator. And the nice thing about this is that basically you can use, you can have a single instrumentation resource to configure auto-instrumentation for multiple of your services, or if you want. So like ideally I could have a section in here for Python and a section in here for Java and a section in here for .NET if I have microservices written in these languages. Or if you want, you can do language specific instrumentation configurations. So you can do some nice mixing and matching, which is awesome. Now, just because we created an instrumentation resource doesn't mean that the application is auto-instrumented. That resource is basically an instrumentation configuration, but we also need to say, hey, what does this apply to? And in order for the operator to actually inject auto-instrumentation to your application, you will need to add a lovely annotation to your application deployment YAML in the template definition section here. And in this example, we have this lovely annotation called instrumentation.opentelemetry.io/inject -python, which we set to true, which tells the OTel operator to inject Python auto-instrumentation into containers running in this pod, and hopefully they're actually Python containers. Now, for other languages, you're doing Java, for example, you replace your inject Python with inject Java. For .NET, you would replace it with .NET, etc. Now, as you can see here, the annotations are added to the pod template definitions for your deployment YAML, or they can also be added to your namespace definition YAML. Now, that part's outside of the scope of this talk. Now, when the pod starts up, just to understand what's going on behind the scenes when we do this auto instrumentation, the annotation basically tells the operator, hey, there's an instrumentation object out there in the pod's namespace, and to inject the Python instrumentation into the pod. Now, what it does actually is it adds an init container to your application's pod called OpenTelemetry-auto-instrumentation, which is then used to inject that lovely auto instrumentation to the app container. But if the instrumentation resource isn't present by the time your service is deployed, the init container can't be created. So if you deploy your service before you deploy that instrumentation resource, things are going to go caca. Now, besides that true value that we saw with the annotation, there are other values that we can set for the annotation. We can set false if we want to temporarily disable auto instrumentation. Or, as you notice, the instrumentation resource has a name. So we can say, hey, we want it to pull the configurations for an instrumentation resource called my-instrumentation. Now, this comes in handy, especially because the way that it works is if you set it to true, for example, then your deployment, the operator will look for an instrumentation resource that is sitting in the same namespace as your deployment. And if you have two instrumentation resources with the same, two separate instrumentation resources in the same namespace, it's going to get confused and won't know which one to pick. So if you have multiple instrumentation resources in the same namespace as your deployment, then you need to specify that instrumentation name. Or if you want to get super duper fancy, you can also have your instrumentation resource defined in a different namespace, in which case you would say the namespace of that instrumentation resource / the name of the instrumentation resource. So that's it for the basics. Now, as we saw with Reese talking about the OTel collector, understanding theory is one thing, but putting into practice is another, and what happens when you deploy the instrumentation resource and things do not work. So let's look at some quick troubleshooting tips. First of all, did the resources deploy properly? So we want to make sure that that instrumentation resource was created in your Kubernetes cluster by running this lovely command. kubectl described OTel inst-n, and the namespace is whatever namespace that your instrumentation resource is deployed to. As we learned earlier, if you're auto-instrumenting via the operator, you have to do things in the right order. So that instrumentation resource has to go first, and then you deploy that deployment resource because of that init container that the deployment creates at the time of deployment. Now, the other thing too, to make sure that init container actually got created, this is a lovely command that took me some blood, sweat, and tears to figure out. So this lists out the init containers for your deployment. If this doesn't come out with any results, then that init container did not get created. So that's probably an indicator. You should go check the order of things. Also check those instrumentations. Make sure that there are no typos in the instrumentation. Make sure that they are in the pod's metadata definition and not in the general metadata definition, because as you know, there are two spots where you can define metadata in your deployment with labels and annotations up top at the highest level of your deployment YAML, and then of course under your spec template metadata. One's right, the other one's wrong. The spec template metadata is the correct spot to deploy, to set that annotation. The other thing is you'll want to make sure that you are auto-instrumenting for the right language, because if your container is running Python code and you're auto-instrumenting for Java, it's probably not going to work. So And then finally, check those lovely endpoint configurations. Like we saw in the instrumentation CR, we do define an endpoint. And if you're pointing to an OTel collector, you need to make sure that you specify the collector name, which is in our case, OTel called -collector. And then if your collector is running in a different namespace than your other resources, then you need that fully qualified name for your collector. So that would be the namespace. In my case, I deployed it to a namespace called OpenTelemetry.svc.cluster.local. And also take a note of the port number. Now, OpenTelemetry Collector supports both gRPC on port 4317 and HTTP on port 4318. If you're doing Python, it only works in port 4318. And I do have a QR code over there on the screen that references that issue. Okay, and then finally, also, if you are deploying your collector via sidecar, your endpoint configuration is actually slightly different. So in that case, you're doing localhost instead. And again, if you're doing Python, make sure that it's that port 4318 and not 4317. Another place to look for things going caca is the operator logs, or in which you would check for any error messages running this command here. This gets you the OTel operator logs. So just do a search on error. And if you don't have access to the operator logs, then you can do a kubectl get events to see all of the events related to deploying your auto-instrumentation resources and your deployments in a given namespace. And this is what it would look like if you ran that kubectl get events. So let us summarize really quickly what we've learned. If you're going to take anything away from this presentation, this is it. So take notes, take screenshots. So first of all, make sure that you install that cert manager first if you are using cert manager, because otherwise, and make sure that you wait for it to complete. Otherwise, the operator installation will go caca. It will not work. Make sure that your custom resources have deployed. I have been in the case where I magically think that things have deployed and actually forgot to deploy them myself. So don't assume, always check. Check that API version, especially for that OTel collector resource, because there are two versions. Don't get them confused. Deployment order matters, especially when we're doing that auto instrumentation bit. Remember to deploy that instrumentation resource before our deployment. Also, annotations matter. Make sure that you don't make any typos. Make sure you put those annotations in the right space, in the right spot in your deployment. Check those endpoint configurations. Make sure that your endpoint exists, is reachable, fully qualified name, making sure it's the correct endpoint configuration depending on your collector deployment mode. And when in doubt, check those operator logs for errors. Literally look for error. All right, and we will leave you with some lovely resources that you can check out. If you are more of a reading person, we do have a blog post version of this talk. You can mess around with OTel operator stuff by looking at the, we have a repo on GitHub that is public where you can play around, and I used a dev container, so you can play around in GitHub code spaces or locally in your dev containers. And there are some other wonderful resources around the OTel operator for you to check out. And of course, the OTel operator channel on Slack, people are super friendly about answering questions. The operator folks were really nice answering my questions. Also, as I mentioned, I have a podcast. My daughter helps me to produce it. And I've had awesome guests on the podcast, including Reese and other notable guests, other CNCF ambassadors, Marina Wijay. I've had I'm blanking out now, but I had Kelsey Hightower on there. I had Charity Majors, lots of really cool guests. So check it out. And thank you so much, everyone, for joining us. And big thanks to Reese's Cat Taco, who is like the best slide model.
Thank you, Adriana. Hope you all had fun. There were some questions. I was getting to them as